what it's giving you is a graph. And we would be able to find all the different things off of it. So if I were to find f of -5, where do you look? You're going to go on the x-axis to -5. I was 5 on my 1, 2, 3, 4. 11. You got count pass mark 1, 2, 3, 4, 5. So here's -5, and you go up, and then you go over and make it 6. Okay, so f of -5 is 6. What would you do to find f of 2? Okay, well that's a good reason, first one. Well, there's a question. With the filled-in dot, it actually has a value. If you have an open one, then it doesn't. No, well, it doesn't have a value. So you go to the dot. So f of 2 is actually 1. F of 4. Yeah. There, so this one doesn't work. Does it really tell you what's going on down here? No. No. So f of 4 does not exist. Or another way to think of that is your function is undefined at 4. You've used undefined on a function before, so there, as I'm talking about it being undefined at that point. So now, let me erase some of this stuff. So we talked about the function values there. Now let's talk about their limit. So the limit, what's that first one? The limit as x approaches -7, so there was 5, so there's -6, -7, has a value of, so not the function value at -7, what's the behavior of the graph at -7? From the left coming up towards, say 2, and it's going to be coming from the right towards 2. So the limit is 2, although at f of -7, it is actually undefined, right? Yeah, because it has an open circle. So that's weird. You can have a limit, but does your function have to have a value at that place? So then, the number 2, the limit as x approaches -5, there's -5, you go up, and it's approaching, again, 6. And the reason behind that, again, is that as you're approaching it, from the left or from the negative side, the number's lower than it, it's coming close to 6. And as you approach from the right, is it coming in number close to 6? Yes. Now, it just happens that the function value is limit. So, as you look at positive 2, here's positive 2 again. You have to look at the graph as it's getting closer and closer. So from the negative side or from the left or numbers lower than it, it's approaching a value of 3. Is it also approaching that value from the right side? Yes. Or numbers higher than it? Yes. Although, what function value does it have that x is equal to? It actually was defined as 2, 1, right? So its function value and its limit are very different. Number 4, f of, or the limit as x approaches 4, here was the line where 4 is. As you approach 4 from the negative side, from the left side, numbers lower than 4, it's going towards 2. But if you look at it from numbers higher than it, or from the right side or the positive side, it's actually approaching -3. Do they agree? No. So this is the place where the limit does not exist. And last year, remember, we used to say NCME is in Beaver, that that wording does not exist. 5, the limit as x approaches 0, let me write this. As we approach 0, you have to approach it both from the negative or the left or numbers less than 0. As I follow my graph, it's actually going towards negative, does it not touch? No, it's never supposed to touch, so it's actually supposed to be negative infinity. I think you kind of look like yourself, but it shouldn't. Negative infinity, as you follow it, and there's an arrow there, as you follow it from the right, or from the positive, or number greater than 0, it's actually going towards positive infinity. Do they match? No, so that one does not exist either. But number 6, if you look at it, it's asking me what is the limit of the function as x approaches 0 only from the negative side. You said that one does exist, that's negative infinity. And 7, as it approaches 0 from the positive side only, it's positive infinity. So limits can exist either from the left or from the number lower than it, or from the right number higher than it. From only one side, but the limit doesn't have to exist at that number. Does that make sense? Yeah. Okay. So if you look at 4 from the positive side only, because remember, I think up here earlier we said 4 does not exist. But if you look at 4 from the positive side only, you have to follow your graph from the positive numbers. I think that's a -3, yes. And if you look at 4 only from the negative side, it was 2. Yes.
Wait, I mixed those two up. 8 and 9. I put 2 and then I put -3.
Remember your x values over here? Over here are positive x's, and over here are negative x's. So if it's coming from the positive side, you have to follow your graph down this way. Coming from the negative side, you have to follow down this way. Sure. It's telling you which direction you are coming from, not which direction you are heading. Because if you had a number line, and I asked you to point which direction is towards the positive, you would point this way, right? And then you're telling me to go negative, you point the other way. So it's not telling you which direction you are heading. You're not heading towards the positive. You're coming from the positive side, following the graph to that number. Okay. If you look at the limit of the function as x is heading towards negative infinity, on the x-axis, where is negative infinity? All the way down until you keep following it, all the way out here, right? Negative infinity. Which is never equal to negative infinity, except for it's heading. What number is it getting close to but never touching? 0. So think about your graph of y is equal to e to the x. It starts way down, goes to 0, gets really small. That has that negative infinity. And from the positive side, if you follow that graph towards positive infinity, if you follow it, it's going towards 0 also. So easy, but I know you thought last year it was the hardest thing ever. I know you thought it. Because you've had another 6 months with me.